If your rulers disagree, who actually decides what 1 meter means for everyone on Earth?
He measures one doorway again and again, yet every tool whispers a slightly different answer. For centuries, every region used its own body-based units, making shared building and science painfully messy. As industry spread, engineers needed one trusted length so parts from different worlds could finally fit together.
They chose Earth itself as a ruler, measuring a slice of its curve instead of feet or kings' arms.
Survey teams inched across Europe, turning hills and villages into numbers along Earth's great curve.
From their measurements, they declared a meter as one tiny fixed fraction of that polar meridian.
To freeze the length, they cast a platinum bar whose engraved distance became the official meter.
In a silent vault, one shining bar secretly decided the length of every bridge and building on Earth.
Metal expands when warmed and shrinks when cooled, making even sacred bars quietly breathe in length.
Scientists locked it in a controlled chamber, fighting dust and temperature to keep one distance unchanged.
They turn to light, whose tiny waves repeat with astonishing regularity, promising a cleaner standard. A special krypton lamp produced one precise color whose wavelength could be counted like tiny steps. They define the meter as a fixed number of those crests, trading a metal bar for vibrating light.
In 1960, they officially tied the meter to Krypton's orange light instead of one fragile bar.
Even special lamps depend on equipment and conditions, nudging scientists to search for something deeper. Lasers arrived, producing light so pure and steady that each beam behaved like a perfect optical ruler.
Suddenly, distance could be carved from pure light, every glowing segment identical anywhere on the planet. They knew the speed of light in vacuum stays constant, a cosmic rhythm available to any lab.
So they froze that speed as an exact number, then let meters be defined from how far light travels.
Now a meter is simply how far light moves in that tiny fixed slice of time in empty space.
High-speed electronics watch light's journey, turning pure timing into repeatable distance with exquisite accuracy.
The dusty metal bar quietly retired as the meter moved into light and the rhythm of time.
Your school ruler secretly inherits its length from lasers and clocks, not from the plastic itself.
Bridges, machines, and satellites all line up correctly because their dimensions echo the same definition of meter.
Scientists even bounce lasers off the moon, timing them in meters to track distance changes by centimeters. Our meter evolved from sticks and metal into pure light, turning measurement into a story about time.
Back at his desk, he sees that simple mark as a quiet handshake with the laws of nature.
Every careful measurement a student makes connects their work to the same global standard of length.
Street widths, room heights, and tracks all quietly depend on that invisible promise of exactly 1 meter.
The meter's journey runs from Earth's curve to metal to atomic light and finally to the speed of light.
Without a stable meter, bridges might not meet in the middle, and precision machines could fail dangerously.
Future standards may use even subtler physics, but they will still anchor meters to unchanging laws.
Marking height at home becomes a little ceremony connecting growth to the same global language of length.
Alex invites you to see every ruler as a story and ask how we know its markings are true.
We promise to explore more everyday questions, whose answers all trace back to careful physics.